guys, today we're looking at specific heat capacity. So we're looking at our calculations on specific heat capacity. Challenge 4, this is on page 6 of your notes. Okay, so please remember that when you're looking at specific heat capacity, if you are dealing with calculations, where we have a change in temperature, we always use the following formula: Q equals mc delta T, where Q is equal to your energy, M is your mass, C is your specific heat capacity, and delta T is your change in temperature. So anytime you have a change in temperature, we may have to use this formula. Okay, so let's look at our question. 400 grams of water. So as we go, we're just going to underline what we have. So 400 grams of water start at a temperature of 15 degrees. So our initial temperature is 15 degrees. The power rating of the kettle is 3 kilowatts. So our power is equal to 3 kilowatts. We want to find the energy required to raise the temperature of the water to 100 degrees. So our final temperature is equal to 100 degrees. Okay, so we want the energy when there's a change in temperature. So we're going to use Q is equal to mc delta T. So I don't know what Q is. I'm told that my mass is equal to 400 grams. Now don't forget to change your units as you go. So if your mass is 400 grams, it needs to be converted into kilograms by dividing it by 1,000. So your mass is 0.4 kg. We need to find our change in temperature. So our initial temperature is 15 and our final temperature is 100. So to find the change in temperature, we take these values from each other. Now remember that your change in temperature must always be a positive value. So it's always the smaller value from the bigger value. So in our case, the change in temperature is 85 degrees. Okay, we're also told the power, but for this, to find Q, we need M, we need C, our specific heat capacity. So this is given in the question, 4,200. So I think I accidentally cut that off for you guys, but you are told that the specific heat capacity, it's of water, so we know it is 4,200 joules per kilogram per degree Celsius. Okay, so we're given our specific heat capacity as 4,200. That's a known value. You would be given that in the question. Okay, and from here we want to find our energy required to raise the temperature from 15 to 100 degrees. So we substitute into our equation. That gives us Q, what we're looking for, is equal to 0.4 times 4,200 times 85. Now you should always have a big value for Q, your energy, because 1 joule is actually very, very small. So multiplying this out, 0.4 times 4,200 times 85 is equal to 142,800 joules. Okay, so we can leave it in that form. If you want to write it as an order of magnitude, you can also. All right, so that's part 1 done. Let's have a look at part 2. So in part 2, we want the energy supplied per second. Now this question has been a bit cheeky. So the energy supplied per second. Well, that's the power value. So the energy supplied per second, let's just give ourselves a bit more room here. Okay. So the energy supplied per second is actually the power value. Energy per second, joules per second. This is equal to your power. Okay, so in this case, you're actually told what your power is. So we're told in the question. So it's just making sure that you remember what power is here. So we're told that the power rating is 3 kilowatts. So your energy is 3 kilowatts also. So if your power is equal to 3 kilowatts, then your energy per second is equal to 3 kilowatts also. So they're the same value. And if we want to, we can change this value into just watts. So kilowatt means multiplying it by 1,000. So that's by 10 to the power of 3. So multiply it by 1,000 to change it into watts. So that's 3,000 watts. So your energy per second is 3,000. Okay, so let's look at part 3. So in part 3, we want the time that it would take to heat the water to 100 degrees. So we want the time in this case. So the time to heat the water to 100 degrees. Okay, so I want the time. Now I know my power is equal to 3,000 watts. And I know the amount of energy required. I found that in part 1. So the amount of energy required is 142,800. So I want the time it would take to give 142,800 joules of energy when the power is equal to 3,000. Well, do I have an equation that links power, energy, and time? Yes, I do. My power is equal to my energy divided by time. Power is equal to energy divided by time. Now, in your log tables, this can also be written as work over time. So I have the power and I have the energy and I want my time value. So from here, I'm just going to substitute in and solve for what I need. So I have 3,000 is equal to 142,800 divided by my time value, which I don't know. So I'm just going to swap out these values, so cross multiply and cross divide, which gives me my time is equal to 142,800 all over 3,000. And then substituting this into my calculator, I get my time as 47.6 seconds. So remember, your power is your energy per second, so your time is here in seconds. Okay, so your time is in seconds. So your final answer is 47.6 seconds. Okay, let's continue on. So in part 4, we're told that in reality, the time taken to heat the water will be much greater. So explain why. Well, we're assuming that all of this energy is going to heat the water. But energy will be lost to the surroundings as well. So when you have your kettle on, not all of that energy, so not all of that electrical energy is being given to heat the water. Some of that energy is being lost as sound to the surroundings. So why? Will the time taken be greater? Energy is also lost to the surroundings. Or is converted into wasteful forms such as sound. Okay guys, so that's our challenge 4. Please go through this video and try challenge 4 on your own.